software engineer at Mesosphere, and we're going to make it in English. Maybe Felix will do the next one in Bavaria, but this one we're going to make it in English.
Awesome.
So what I would like to speak a little bit, maybe not even a little bit, about Mesos, one of the parts that Johannes touched before, and DCOS, that's the project that we built on top of Mesos at Mesosphere. But before we start, how many of you have contributed to Mesos? Okay. How many people maybe wrote a Mesos framework or played with the Mesos framework? Okay, a little bit better. How many people used Mesos just without writing framework, just used Mesos? Okay. How many people have heard about Mesos? Okay, that's great. And maybe there are some people who didn't hear about Mesos but heard about Yarn, Kubernetes, or Google Work, Google Amiga. Okay, good. The reason I ask this question is because for me it's always a little bit challenging not to bore people who already know things, including myself, and not to lose people who do not know things. So I'm glad that almost all of you have heard at least about Mesos and you understand what Mesos is. To summarize what Mesos is Mesos is the distributed system that we write in order to facilitate writing other distributed systems on top. Because writing distributed systems is hard, there are a lot of problems, and we don't want other people to solve these problems again and again. For clear reasons. It's expensive, it's error prone, and why not giving people a tool that they can use in order to write their distributed systems better and faster. So Mesos lets you to treat your cluster not as individual machines and not as individual nodes, but as one big computer, like this one, or maybe even like this one. The world that we try to be in is to give programmers not a bunch of machines that they have to program on or to deploy on, because people do not want to deploy applications, say on put these applications onto machine number 1, number 3, and number 5, and maybe number 7 and 8, because I know that number 7 and 8 are in the different data center. They just want to run the applications in somewhere and maybe put additional constraints, like I want to have 5 replicas and I would like to have at least 2 of them in a different data center, maybe in a different part of the world over the ocean. And the world that we would like to be in is that to unite all these computational resources under one umbrella and just to give developers or data center operators these resources as chunks. And we recently talked with Ben Heinemann, the author of Mesos, and it looks like, or at least maybe we hope, maybe we're too optimistic, that the future where there will be no racks, no computers, no data, well, there will be data centers, but in data center there will be just a bus. And if you need more CPUs, you just put more CPUs, attach more CPUs to the bus. You need more memory, you attach more memory, and just one address space. So no more nodes, no more computers, just a bus where you attach different computational resources, storage and memory, CPUs, whatever. That's how we run the data centers today. And it doesn't make much sense. Well, we used to run the data center this way, but it doesn't make much sense to run them this way. Some facts about Mesos, though maybe you don't need them, because you have already heard about Mesos. Mesos started at the research project at UC Berkeley, and then it was hardened in Twitter. Now it's open sourced. It's a top-level Apache project. It's battle tested. There are a lot of people who are using Mesos, not only people but companies. For example, Sear runs completely on Mesos. Twitter runs completely on Mesos. 40%. What's that?
Only 40%.
Of Twitter?
Yes.
Completely 40%. They say they run completely.
Almost completely.
Almost completely. Since you touched this topic, for example, with Mesos, so they run almost everything on Mesos. What do you think their utilization is? CPU, let's say CPU utilization.
Don't know.
Any guesses?
What about 80%?
Okay, one guess. Let me extend the question. So what was the utilization before they switched to Mesos and after of their cluster?
30 to 60.
Okay, so before Mesos it was less than 10. With Mesos it's less than 30. So even with current state, 70% of your CPUs they're just idle, which is not environmental friendly. Which is maybe an argument in Germany. It's not an argument in the United States, but maybe here it can be an argument. And that's something what Johannes touched before, is that if you put all your stuff, all your application into one data center, and your different applications have different spikes and different time frames, then you kind of can reuse these computational resources taken in from one application to another, if they have different spikes. If you have applications that do not really need these resources and may, say, start when there are idle free resources in the cluster, then you can do even better. You can reserve almost everything for production applications, and then when production applications do not need these resources, you can let your batch applications run and use these idle resources. One of the reasons of this talk is, for me, that's actually maybe not the reason, but that's a goal that I have, is to explain you a little bit more what is Mesos, what problems it tries to solve, in what direction we move, and therefore how you can benefit, or maybe whether you can benefit from it. Maybe you don't need this fancy thing called Mesos. And this is, I would like to introduce a terminology. It's not an official terminology. That's something that only I use, so you will never ever find it on official websites. But I think it helps understand what Mesos is. I call it Mesos dichotomy. There are two big parts of Mesos, or problems that Mesos tries to solve. One part is called plumbing, and the other one is scheduling. So the first one, plumbing. So what's plumbing? Does anybody know what's this picture? What's on the picture? What's that? Any ideas? What's that on the picture? I think there is an idea there. No?
Wires?
Yes, wires. Which wires? Okay. So these are superconducting links from Hadron Collider. So it's wires, but without these wires, the whole experiment, the whole fancy experiment is not possible. So this is something that people don't really know, don't really pay attention. It's something behind the scenes, but years of research is behind these wires. These are just wires. And that's something, same in Mesos. There are a lot of crucial but not exciting components like containerization, supporting all this Docker stuff, isolation, task cleanup, task artifact distribution, failure detection, monitoring, all this stuff there is in Mesos. It's not that exciting, but without this, no one will use this such a scheduler. So you can play with your fancy scheduling, maybe you can even write a thesis or an article, maybe you can even have a PhD, but if you don't have all this stuff, no one will run your scheduler in production. 1 year ago, maybe even, no, 1 year ago, the DockerCon, I was telling people that how cool now we support Docker in Mesos and in Mesos frameworks that we support at Mesosphere. Today, well, you cannot impress people if you support Docker. Everybody should, and if you don't, well, we're not even looking into your direction. So what's changed is since then, we support not only Docker, we are now, together with Twitter engineers, adding support for AppC and Rocket. We are writing unified containerizer that will support everything that in future may come. The thing that I mentioned in containerization out of all that plumbing stuff is that, additionally to what Johannes said, from my point of view, the biggest thing that containers provide, yeah, of course, it's fancy packaging. You just put all the stuff in, like into fat binary. Like on macOS, it's easy to distribute. But the most important thing is isolation. All the security problems, they will be solved. Maybe next year, maybe over the next year. I'm pretty sure that containers will be as secure as VMs now. But they provide isolation, resource isolation. from resource allocator or from cluster management perspective, if you cannot isolate, you actually cannot do anything. If I have 2 apples and I give 1 apple to Felix and 1 apple to Johannes, and then if I cannot prevent Felix from stealing this apple from Johannes, I do bad job, I do poor job. I'm not really allocating because they can do whatever they want with their apples. That's why containers are, I think, very important because they are lightweight and they still provide isolation. As I said about all this plumbing stuff, there is a lot of work that is done that we are still doing. I've talked to somebody today and he said me that security is something that they're interested in. We added SSL to Mesos recently, and there will be security support in DCOS next releases. There are task hooks that allow you to schedule something on different Mesos events. For example, that's how Calico is supported in Mesos. And one use case is why Calico is interesting. Again, guess why Calico is interesting for us? It's isolation. So we can isolate network bandwidth with Calico, and it's IP per task or IP per container. So each task can get its own IP, and you don't need to deal with all this port stuff and whether this port is available on machine or there is an application that needs port 30 and only port 30 or port 80 or 8080, and there are 2 of those and they both need 8080, and no one would like to use 8081. If you have an IP per task, that this problem is gone. And if you can isolate network bandwidth, it's even better. We have maintenance primitives that allow operators to drain agents. Twitter was looking forward to this feature because they have thousands of machines and they would like to schedule them for maintenance without killing tasks, and to give framework the right to Mesos framework the right to finish the task gracefully or let the task finish. Authentication and authorization, and as I said, new containerization primitives. Docker support is something that everybody asks. As I said, now we not only support Docker and we work on adding support for other containers, we also support Docker Swarm. There is a Swarm Mesos framework. So, for example, we have a team of developers that use Docker and they play with Swarm, and then you would like to pull out Swarm and still keep Docker and use Mesos instead. You can easily do it with Docker Swarm framework. And unified container, that's something that is being developed now by Mesosphere and Twitter, and hopefully one day it will be very, very easy for Mesos framework writers to use whatever containers are available on the market. As I promised, I will also speak about DCOS and what DCOS adds on top. Very often people ask, so what's your DCOS, or what's the difference between Mesos and the Mesosphere stack, or Mesos and DCOS? And DCOS, there are several differences, and as I hope to see benefits, not only differences. And one of those differences, they touch plumbing. For example, with the DCOS, DCOS provides a CLI, and instead of installing all these frameworks and services yourself, you can, in your favorite terminal type DCOS package, install something like Cassandra, and Cassandra is being deployed in your Mesos cluster, somewhere with the amount of nodes you need. So you don't have to configure anything, or you type DCOS package install Quobyte, and you go to Quobyte installed into your DCOS cluster. Another thing DCOS provides is embedded support. It's there, it's white background, that's why maybe it's not that visible. So if you have a DCOS, even if you don't pay for DCOS, if you have DCOS Community Edition, you can click a button and get support right there. A nice UI that integrates information from all the frameworks running in the cluster and Mesos itself, so you don't have to go to remember, oh, what Mesos UI is port 5050 or 5050? Oh, on Mesos Agents is 5051, and on Mesos Master is 5050. And your framework Marathon runs its UI on 8080, I suppose. And I don't even know, I'm pretty sure that HDFS framework has its own UI, and I also have to look up the port number. So with the integrated UI, it's much easier. For me as well, it saved me a lot of time. Last but not least, what DCOS adds on top are things that help you to bootstrap the cluster. So you can take Mesos, build it from source, deploy it on your machines, write in maybe a bunch of salt scripts or Puppet, whatever, or you can click a button in AWS. Well, you have to pay AWS for this, but you click a button, you say, I would like to have a Mesos cluster with 10 nodes, and you will get 10 nodes in AWS, a DCOS cluster with 10 nodes in AWS. We have some, fortunately or not fortunately, spent some nights getting operational expertise, strange issues on those fancy new technologies and OSs like CoreOS that try to launch everything in containers, and if you would like to start another container from this container, and then your container dies, and you would try to regain the ownership of the container started before, it's kind of difficult. And if you don't know how to deal it, it may spend you a lot of days if you ask somebody who knows. And another thing, people often ask about service discovery. So you have applications in your cluster, how these applications can find each other. And we have a client, it was a big surprise for us, they don't have DNS in their data center, so at all. It's a big client, I'm pretty sure everybody know this American company. For me it was a big surprise, they don't have DNS in their data center, and you have to deal with it. Oh, and security enhancement, but I have already mentioned this. Now the second part. This is something that people don't really know that exists. And they don't usually ask for this, but this is something that can save a lot of money. That's something that helped Twitter to increase utilization from 10 to 30. And once we improve this, I hope it will go from 30 above to maybe 80 one day, though I don't really think so. But this is something that saves money. The bigger cluster you have, the more money you can save. The basic algorithm that is used by the default built-in Mesos allocator is called dominant resource fairness. It was developed in Berkeley, and it's said that it's fair. So it provides you fair allocation. The question is, what is fair? For example, several allocation scenarios. I'm a cluster manager, and my resource is scientific calculators. So I'm giving scientific calculators to people, and I have two guys. For example, you guys, you would like to use my scientific calculators. I have 6 of them. So what is fair? I give 3 to you and 3 to you, right? Fair, pretty much. Everybody's happy. Now he comes, registers, and you remember all the security stuff. So I checked him, he is allowed to get calculators as well, but I don't have free calculators for him. So what is fair now? Shall I just wait until these guys say, well, I don't need these calculators anymore, you can get some? Or is it fair to get one calculator from each guy and give 2 to him? I don't know what is fair. Okay, another use case, a similar one. For example, I have 6 calculators, and again I give 3 to one and 3 to another one. But the first one says, well, right now I'm lazy, or I have nothing to do. So I will get 1 and 2 you can get back. Now I have 2 calculators and I have nobody who are interested in the calculators, so I give these 2 to the other guy. He says, yes, okay, give me calculators. Now everybody's happy. He has 1 calculator, he has 5 calculators. Everybody's happy, all is fine. But then something happens. For example, German authorities create one more tax regulation, and this guy needs 1 more calculator to get this tax calculated. But I don't have free calculators for him. What shall I do? Shall I get 1 calculator back from this guy? But when I was giving him 2 calculators, I promised it, well, these are calculators you can use. So what is fair in this situation? have one more scenario. Suppose I have just 2 calculators. I'm running out of calculators, and everybody here is interested in calculators, but not now. So Felix needs 1 calculator, so 1 calculator goes to Felix. I know that Felix uses this calculator, so I have just 1, and I'm not going to give this 1 to Felix because he has already 1, and you have no calculators. Then I come to you and ask, do you need a calculator? He says no. Do you need a calculator? He has no. But they both say no, but maybe in 5 seconds I will reconsider. He said the same. No, but maybe in 5 seconds I'll reconsider. When I end this round, 5 seconds already gone, and I cannot go to Felix and to offer this 1 calculator, but he needs this calculator because I have to start all over again because 5 seconds are gone, which means effectively 1 calculator is blocked because it takes a lot of time for users or Mesos frameworks to reject this calculator. Again, is it fair? Maybe, but to whom? So the problem is that, as I see it, there are no silver bullets here. And that's why I always encourage, one of the reasons I always encourage people that write their own allocators. Another reason is because that's my baby, I modularize the allocator. But the biggest reason is I encourage people to write their own allocators. Because these scenarios, they're real world scenarios. They're coming from our clients. Or not only clients, doesn't matter. So the last scenario, for example, is, I think it's public. So Apple, for Siri, they run more than 200 frameworks, and they saw this starvation case. When there are enough resources, but frameworks that do need these resources, they're not getting these resources because a lot of other idle frameworks, they just reject resources for some time. We work around the problem, but again, maybe the built-in allocator is not the right allocator for Apple Siri. So now it's possible in Mesos to write own allocators. Again, I got a question about stateful services today. That is something that would be nice to have in Mesos. We know that, we are working on this, and we added persistent primitives and dynamic reservations to Mesos. Now just have to wait or motivate framework writers to make use of these persistent primitives and to provide stateful frameworks like Cassandra using Mesos persistent primitives. Oversubscription, that is something, it's one of my favorite. By the way, all these are links, so this presentation is on the internet. You can later on go to this thing called internet and click the links, and you will be redirected to YouTube or articles, whatever. Oversubscription is something that is one of my favorite things. People don't know about oversubscription. Because they don't know, but that's something that again can save you tons of money. Because if you say, I need 1 calculator, and you just don't need this calculator, but this calculator sits somewhere in your table, and I have zero idea whether you use it or not, but I can inject a spy on this agent to check whether to use this calculator, and if you don't use it, I can just borrow this calculator for some time and give it to somebody who can use this calculator. And once you come and say, oh, where is my calculator? I will give it back to you right now. This is what we call revocable resources. And frameworks may opt to use revocable resources, which may be obviously revoked any time when the owner of the resources tries or wants to use them. So this is something that we've done together with Intel, and I think so one of our clients, they are using this and they increase their utilization by 20% using a dump oversubscription, a very, very dump oversubscription module. Quota, that's something we'll end right now. Quota allows you to reserve certain resources to avoid several starvation cases, as I described at the beginning. When the 2 guys, one gets 1, the other gets 5, and if I set a quota, well, okay, your quota is 3, which means anytime you want this 3 calculators, you will get them no matter what. We will end quota, I think, in the next 2 weeks. Optimistic offers, inverse offers. Inverse offers are part of maintenance, which means we can, instead of giving resources to framework, we may ask a framework to give the resources back, which is a nicer version of preemption. And again, icing on the cake, smart oversubscription modules that we sell, and anomaly detection. Again, with the client base, with the bigger clients, we can extract all the data and the statistics, the usage statistic, and try to learn from the usage statistic, and then build modules or improve modules based on this usage statistic, and sell them instead of just giving them. And to wrap it up one more time, what is the difference between DCOS and Apache Mesos? Though DCOS is based on Apache Mesos, there are several differences, as I said. And DCOS exists in two variants: Community Edition and how do we call it? Not Proprietary Edition, but Enterprise. Yes, Enterprise. The first one is free; everybody can use it. The second one is obviously not. So what you can do, I call it the Gantu way. I think that's what you guys are doing. You can get everything if you don't trust companies, especially American ones. If you don't trust companies, American companies, especially startups, you better go to GitHub, check the source code, compile it yourself, and then try to deploy and figure out how it all works and what all these strange parameters in Mesos and Aurora are. Instead of building this everything yourself, you can go to mesosphere.com and get already packages for your operating system. You still have to configure them yourself, but that's at least something. You don't have to compile it. Or you can use the Community Edition and get already everything prepackaged, and maybe with a little bit sugar on top, like UI I mentioned, or built-in support. Yeah, we also have support is built in the Community Edition as well. So every time you write a question in the Community Edition, some of our support guys gets a message and then comes to us engineers and asks, "Oh, well, you have a question here. Could you please help me to solve it or to answer it?" However, some companies have much more moving parts, like same as Apple. They have their own data centers, they have their own policies, they have their own discovery solutions, and they have integrated all this Mesos stuff and what's run on top of Mesos into their own data center. So they have much more moving parts, and normally, even with Mesos, they have teams with more than 10 people who try to assemble all this together. One of the good examples is the hedge fund 2 Sigma. They actually open source their scheduler Cook, which has, interestingly, different views on what fairness is, and they have their own own allocation algorithm, which is modified version of dynamic resource fairness, because their use case is they run financial simulations a lot, and for them it's very important to give everybody from the team, every researcher from the team, a certain amount of compute time. So for them, preemption is important. In Mesos, we do not do preemption because we cannot, by default, randomly kill tasks by other people, started by other people. So yes, you can do it yourself, or you can use the Enterprise Edition and get this already assembled. I wanted to show some demo, but I got sick in misty Hamburg, and instead I put a video here from the MesosCon Seattle. If you want, we can show this video. That's how I can start the video and I can talk in background. So this is the video from one of the keynotes from MesosCon Seattle. That's the partner project for Mesosphere and Verizon. How you can start a lot of containers in no time on Mesos and Marathon using DCOS. And there is the visualizer. This is just a fancy visualizer that lets you understand that there are 4 different apps, and each app has so many tasks, and then the sequence how the task and these applications are started.
But these are 30 seconds or 38 seconds.
Yes.
It's real time.
Yes, it's real time. Moreover, I haven't been to this DockerCon in Barcelona. They did this very similar. They even wrote a similar visualizer. The only difference, and they also have some good timing, I would say. The only difference is they don't care about the feedback. So here, you don't just start a task, you get the feedback the task is started and running. And all these 50,000 messages request that the task should run, then you get a receipt, then the ACK receipt from the agent. they all pass through the Mesos master, and this Mesos master sends them back to the framework. That's all included into the 38 seconds.
No, actually, they needed 30 minutes.
Docker, 30 minutes with Swarm?
I think so, yeah.
I think it was faster.
No.
Okay,
It's
that's
not-
why when you
but-
hit this scale, you take out Swarm and put Mesos instead.
You need to double check, but I'm pretty sure that
Okay.
was a footnote.
And yes, as I said, you can go to this presentation. It's on the internet, and if you know somebody who may be interested into working on this stuff, either plumbing or scheduling, they can hit this link or write directly an email to me. We need helping hands, a lot of them, both in Hamburg and in San Francisco. Any questions? Shoot.
First question would be, would you prefer to write your own framework or to use something like Marathon? So for example, I could run a Cassandra database with Marathon, or I could use the Cassandra Mesos framework. So what would you prefer to use?
That's a good question, and I think there are two parts of the answer to this question. First one is, depends on what your task is. In case of Cassandra, most probably you would like to persist the data. So you need somehow to tell Marathon that for this task, you would like to persist the data. And maybe you also want to do some sort of smart reconciliation. And Marathon is just, it's a meta framework. It can do everything. And and because it's so general, it may not be very well suited for Cassandra. And I think that's why we have a Cassandra framework, especially for Cassandra. A very good example is Elasticsearch framework that is developed by our partners in Amsterdam, Container Solutions. So the only reason why it makes sense to start Elasticsearch charts using a special framework is because they have a non-trivial mechanism with how they register with each other. So from Mesos' point of view, what a framework can do, a framework can start a new instance, but it's not that easy to connect this instance to instance that already started. The new instance has to report somehow back to the scheduler, and the scheduler has to update already running tasks. Instead, you can write a special. Sorry, I think I lost you. So the thing is that if you start this chart via Marathon, and Marathon start this chart as a task, you need a special hooks that you will run right after the task is started, that will discover all the shards you started before and report that there is one more. You can do it, and it was the hack our CTO done in like 2 days when there was no Elasticsearch framework. They just wrapped it basically into the script, wrote a simple discovery solution, and it was possible using Marathon. However, now with the framework, the only reason the framework exists is because you can control when you start a shard, you know where all other shards are, and you can tell them that this is the new shard, welcome the new member into your family. So it depends. I hope I answered your question. That was the first part. The second part is that, unfortunately, though we really would like to make writing distributed systems easy, we're still not there yet. And a real-world example, in Twitter, there are also engineers that come to their managers that say, well, I would like to write a framework for this and this and that. And the manager tells them, well, we already have a framework, Aurora. Just add your functionality to Aurora. No, I would like to write my own framework. The problem is that in Aurora, they have already implemented a lot of stuff like user authentication, quotas, grouping, whatever. And if you write your own framework, you have to re-implement it. You can reuse stuff that is in Mesos, but now we don't have everything in Mesos. We would like to provide the framework developer kit and put everything there, like quotas, authentication, but we're not there yet. That's why I said we need helping hands, because there are a lot of things to do. That was the second part of the answer.
Thanks.
More questions? It looks like that was too much food.
What is the timeline for oversubscription?
Oversubscription is there, so you can go and write your own module for oversubscription. So what's in Mesos? In Mesos, there is an oversubscription module. It's not a module. Oh, now I forgot an English word. A German word is Schnittstelle. Interface. So there is an interface for oversubscription, and I think we provide a very, very stupid oversubscription module as an example, which just oversubscribes 20%, for example, or 30%. But you can write your own model for oversubscription, yes. Or buy one from us. Any more questions? Okay, then Felix.